Okay, hello everybody. Good morning. I'm gonna make this very quick, yeah. Okay, so basically, tomorrow is your exam, right? And I just suddenly got some inspiration, huh? Don't ask me how I got these inspirations, but I just suddenly got some inspirations, for certain topics, lah. So I want to discuss with you all. So I'm just gonna go through this very quickly. Because on YouTube you can set your own speed. You can just set at the YouTube video settings. You can make this video slower. If I'm going too fast, you can replay many times. Okay, so I'm not gonna because I try to make this video as short as possible. Okay, so right, let's go into the topics. Now, the first topic, right, that I have a bit of inspiration on is on the thermometer. Okay, so let's just say they ask you, what is the meaning of sensitivity? Okay, so the sensitivity of thermometer, right, is basically how sensitive are you to any change in temperature? If you change the temperature, does the thermometer know or not? Okay, so you can say it is the ability to detect small changes in temperature. Okay, the ability to detect small changes in temperature. Now, how can you make this thermometer more sensitive? There's one way, which is to you can say decrease the wall thickness, decrease the glass thickness of this portion here. This portion is called the bulb, lah, bulb. Okay, so you can say use thinner bulb wall. Okay, that's one of the ways, right? A thinner wall of glass at the bulb. And also in the middle, right? This part where the liquid goes up and down, we want it to be thinner. So thinner capillary tube. The middle part where the liquid goes up and down is called the capillary tube. Okay, so thinner capillary tube or decrease the diameter of the capillary tube. Okay, and in case they ask you about the liquid inside, right? Most common we use mercury and alcohol. Mercury is usually for hot objects because it has a high boiling point, so it doesn't boil easily, unlike alcohol. But for cold objects, we use alcohol because alcohol has a very low freezing point, which means alcohol doesn't freeze very easily. You can measure very cold objects. Okay. Now, mercury is toxic. Alcohol is considered safer. Alcohol is also considered cheaper. Yeah, easier to obtain. But mercury is opaque, means that it is not transparent. Alcohol is transparent. So mercury not transparent, it's easier to see. Okay, these are the advantages lah, right? Mercury actually changes temperature faster also. It is more reactive lah, we can say. Okay, more reactive to temperature change. So it will show you the final temperature faster. Okay, so that is the advantages of each of these things lah. Okay. Now, the second topic I have some inspiration about is gravitational force. So for gravitational force, right, basically the main thing they might ask is the Newton's law of universal gravitation. That's what we're going to call this here. Newton's law of gravitation or universal gravitation. Gravitation, okay? Or Newton's universal law of gravitation. I think so. I forgot which one is it. You check your own book, lah. Okay. So basically, it's this formula. It's this formula of F equals to Gmm over R squared. Okay. So just to remind you, F is the gravitational force. G is the constant, gravitational constant. They will give you in your formula sheet. And then the 2m is the mass of two objects. Because this gravitational force, we always try to find the force between two objects. Okay. And then R is the distance between two center. All right. So let's say I got one object here and I got another object here. R is from here to here, center to center. This is the R. Okay. Right. Now, the definition, in case they ask you, the definition is actually based on the formula. So what you have to tell them is, you have to tell them, okay, why universal? Universal because everything also got this. It applies to everything one. So you can say all objects in the universe. Okay? All objects in the universe or everything in the universe. Who does it attract? The object has a gravitational force with who? With everything else. For example, if I have my pencil here, this pencil and me got gravitational force. The pencil and the chair got gravitational force. The pencil and the wall got gravitational force. So all objects in the universe attracts every other object. Okay, attracts every other object. Now, you haven't mentioned the formula yet, ma. So how much is the attraction force? You say, with a force that is, okay, so now we see the G never changed one. It's a constant, so we don't care about the G. Let's look at the mass. I take one mass and another mass and I times together. So we can say product of mass. Okay? If this product of mass increase, the force will also increase. You put in the numbers, you will know. So we can say the force is directly proportional. The force is directly proportional to the product of masses. Okay, directly proportional to the product of masses. Okay, and let's look at the bottom. The bottom, what is this? What is the R? R is the distance between the center. Correct not? Distance between the center. But I want R square. Then I will say square of distance between the center, or distance between the center square. Correct not? Okay? Then if this number increase, my F will decrease. If you don't believe, you put in some numbers. This one go up, this one go down. Then I will say inversely proportional. The force is inversely proportional to, remember the square, to the square of distance between their centers. Cannot just say distance, you must say distance between their centers. Okay, so that is how you get the definition of this law. Okay, it's based on the formula and based on universal lah. So then you just put in the formula and calculate lah. Okay. All right, another topic that I got some sudden inspiration is about the interference of wave. So interference of wave is you got two waves, and then the wave got up and down, up and down, up and down, all right? Yeah, the up we call the crest, the down we call the trough, okay? And then sometimes the crest and the crest will meet, or the trough and the trough will meet, or the crest and the trough will meet like here and here. Okay, so this will form what? Constructive and destructive interference law. They ask you, hey, why this place got loud sound? Because you say the crest and the crest superposition. You use this word. When you want to say meet, you say superposition. Yeah, for example, they ask you, hey, why here got loud sound? Then you say, oh, because here the crest and crest superposition. Crest of one wave and crest of another wave superposition. Then what about here? Why here got soft sound? Because the crest and the trough superposition. That one we call destructive interference. If up and down, that's called destructive. Okay, so meet together. See what happens. Constructive or destructive interference. Okay. And then the formula lambda equals to AX over D. Make sure you know what all the things are. So the distance between the source, that's your A. Okay, that's your A. The distance from one node to the next node, or one antinode to the next antinode, is your X. Okay, so meaning from loud to loud or soft to soft, that is your X. Okay, so if I were to find an example here, let's say you see here and here. This one is one. Okay. Here actually also this one, oh sorry, actually should be this one and this one, I think. Yeah, a bit hard to tell from my drawing lah, but supposedly, let's say you have loud, soft, loud, soft, loud, soft. Okay, loud to loud, that's your X. Or soft to soft, that's your X. Okay? And then D is the distance from where you measure the A to where you measure the X. Let's say you measure the X here, right? This is the D. Okay, the distance between the source and your result. That's the D. Okay? Yeah, if you need to write this down or something, you just repeat. You just go back a few seconds, then you repeat what I just said. Okay, then the next thing they will ask, if let's say they ask you to do calculation, right? The next thing they will say is, if I do this, what will happen to that? So for example, if I bring the source closer, what will happen to my loud sound and loud sound distance? So they're asking you, if my A go down, what happened to my X? So what I want you to do, right, is I want you to just change the number from your calculation. If let's say just now you do your calculation, is 5 equals to 3x over 2. They ask, what happened if I reduce the distance between my source? I want you to change this to another number. Let's say reduce, I change to 1. And I just want you to count a new X only. Count a new X. Then you will know, oh, my X will increase. Okay? So that's how you answer this kind of question. If this thing happened, what will happen to this? You change the number in the formula and you calculate a new answer for me. Okay? Everything else, you just remain the same. Yeah? Okay. The next topic that I have some inspiration is about lens. Okay? We got convex and concave lens. Make sure you remember for convex, right? The light is supposed to go to the F. Okay? The light is supposed to focus at the F like that. For concave, don't have one. Concave is go out one. We call this diverging. Okay? So convex is converging because all the light come together. Concave is diverging because all the light go away. Okay? So if you want to do any ray diagram drawing, this is what you do, okay? So let's say this is your object. All right? You go horizontal, the light ray is horizontal, then you go to the F. Okay, go to the F. The second light ray, you always pass through the middle, the center point. Yeah? Second light ray always pass through the center. Whatever the location here, doesn't matter. The steps is the same one. And then you try to find the two intersection point. If they intersect here, then your image is here. If they don't intersect here, they become wider and wider. Then you have to trace back, use dotted lines. Your image is here. Okay? Yeah, trace back using dotted lines. If they totally cannot intersect at all, parallel, you also trace back, but your image is now at infinity. Okay? Right? For concave, this is your object. Okay? You go there straight, but then you go outwards. But this outwards is not random one. You must always be able to trace back to the F. That is how you know where does it go. Okay? The second line, same thing, always go through the middle, the right straight through the middle. Okay? So your image is here. Image is here. Okay? Make sure you know how to differentiate. If got dotted lines, that means it must be virtual. Okay? If got no dotted line, let's say this one, they meet, and then you never use dotted line one. They meet like that, never use dotted line. Then we say it's real. Okay? Then the rest, I think you know upright or inverted, magnified or diminished or same size. Okay? Now, the next thing is the lens calculation, lens formula calculation. F is the focal length. This one, focal length is your tiny little f. U is the object distance. That's your U. V is the image distance. That's the V. Okay? So normally they will ask you to find image distance normally okay? But it depends also You can choose to change to meters or just leave it as cm also can because the answer come out will be the same. Okay? Just take note if you have convex your F must be positive. If you have concave, your F must be negative. All right? For this one, for your calculation. Okay? And your image, if the image come out is positive V, if it comes out as a positive number, this is real. If it comes out as a negative number, this is virtual. Okay? And then your object and image distance will tell you whether it become big or small. Okay? If the distance is nearer, that means it becomes smaller. Okay, you see or not? This object is so far away, but this image is so near. That's why this image is smaller. Nearer means smaller. Further means bigger. Because you are magnifying the flaw. So you are magnifying your object also. Okay? And the last one, spectacles. Okay, how to know which spectacles to use? Because, right, this one, okay, is to focus the light more. So if you have trouble focusing the light, for example, your eyeball cannot focus the light well. Your eyeball focused too far already. So now you need help to focus the light, then you use convex to help focus the light, okay? Inwards so that you can meet on the retina, okay? But if your eyes focus too much already, then I need a lens to spread it out. So how to spread it out? I will use a concave. Yeah, concave, then it'll help to spread it out like that. So it'll fall on the retina. This one have to focus a bit, so it'll fall on the retina. Okay, so that's for spectacles lah. Okay, the next topic I am interested in is ticker tape. Okay, again, all these topics, I don't know where it come from. Just suddenly I sleep, then boom, got inspiration. Okay, so ticker tape. So first of all, what is the meaning of frequency, right? It's the number of complete oscillations per second. Number of complete oscillations or vibrations per second. Now, if they never mention what is the frequency, you always assume 50 hertz, which means you always assume 0.02 seconds for one tick. 0.02 seconds per tick. And just to remind you, one tick is this. Jump one time is one tick. Don't count the dots. This is 2 dots, but this is only one tick. Okay? Right? 0.02 seconds, one tick. Okay? Now, if I want to find the acceleration, I will have to use my formula A equals to V minus U over T. Okay? To find the initial velocity, I need to know where start first. You see this arrow? The arrow always point to the start. The other side is the end. Okay? The arrow always point to the start. Understand? So your U, you calculate using this one. Your U is the 6 centimeters divided by, this is 1 tick. So 0.02 seconds. The V will be the other side of 3 centimeters divided by also 1 tick. So 0.02 seconds. Okay? So after you get these two numbers, you can put inside the V and the U. Okay? And then the last one is the T. This T, you must measure from here to here, you know. You don't measure from the first dot. You measure from where do you calculate U? You calculate U using the whole thing here. This is your U. So normally, how do I start? I start from the middle. Because I cannot start from here. If I start from here, then he say, hey, I also cut off U. So you must start from the middle. You jump 1. Okay? And then you jump 2. And then you jump 3. You jump 4. And then you jump 5. You see, I'm in the middle of the V now. From the middle of the U to the middle of the V. Okay? So total only got 5 jumps only. 1, 2, 3, 4, 5. So 5 times 0.02. Okay? That is how you get the acceleration. Can use cm per second. This one can, no problem. Okay? Now, if it's a ticker tape chart, same thing also. You want to find your acceleration, you need your U, you need your V. The U is always the first strip and the V is always the last strip. So your U is, let's say this is in centimeters lah. So your U will be 8 centimeters divided by how many jumps here? You can just look at the longest one. 1, 2, 3, 4, 5, 6. So 6 times 0.02 seconds. Every strip is going to have the same number of jumps, so you don't have to worry. Every strip is the same number of jumps, okay? Now, for the longest one, it will be 20 centimeters divided by, again, every strip got 6 jumps, okay? Right? So now you can take your U, put in here. You can take your V, put it in here. The T, again, the T, let me show you how to measure the T. From here, jump to the V. From the U, jump to the V. So this is 1 jump, 2 jumps, 3 jumps. So this is 3 jumps. Every time you jump, you are going through the whole strip. The whole strip got how many? The whole strip is 6 times 0.02. So this is the T. You jump 3 times. Every jump, you are jumping through 6 times 0.02, 6 times 0.02, 6 times 0.02 in order to reach your V. Okay, so that's how you get your acceleration for ticker tape chart. If they want the average velocity is total distance divided by total time. And how do you find the total distance? Just add up all the lengths together, right? 8 centimeters plus how many centimeters plus how many centimeters plus 20 centimeters, just all of the length, you just add up together, okay? The total time, just like I said, one strip is 6 times 0.02, right? Then, how many strips here? Total got 4 strips. Not the jumping, total, everything. This one is jumping because this one I want to know from U to V, how many jumps. Now I want total. Total got 4 strips, so times 4. Okay, so that's how you find the average velocity. All right. Now the next topic will be on F equals to ma. So the resultant force, remember this F must always be resultant force or net force. Okay, how do you get resultant or net? You take the right side minus the left side, or you take the up minus the down. That's called the resultant force. Okay, if there is only one, you confirm there's only one. There's confirm no friction, no nothing. Then okay, you can use this as your F. Okay, but just remember it's a resultant force. And if something moves at constant velocity means that the A is 0, no acceleration, which also means, okay, the resultant force is 0. Okay, what does it mean? Resultant force equals 0 means up is equals to down, left is equals to right. That's the meaning of resultant force equals to 0. Okay? Yeah, everything is balanced. Okay? All right, the next topic, specific latent heat. What is specific latent heat? It is the heat energy required to do what? Heat energy required for 1 kg. That's the specific mass. Specific is 1 kg mass. 1 kg of substance to change phase. Change phase means what? Means solid to liquid, liquid to gas, gas to liquid, liquid to solid, like that. Change phase. Now, normally you change phase, right? It will always be at constant temperature one. Okay? It will always be constant temperature. Why? Why constant temperature? Because the heat is used to The heat absorbed is used to, okay, if let's say you are solid going to liquid, then you are weakening the bonds. From solid to liquid, you weaken the bonds. From liquid to gas, you are breaking the bonds. Heat is used to break the bonds. If you go from gas to liquid, gas to liquids, you have to form back the bonds. Correct or not? Gas to liquid, you release heat, you form back the bonds. From liquid to solid, you strengthen the bonds. Okay, strengthen the bonds. It's the opposite lah. Weaken then strengthen, break then form. Depends on, are you going from melting? Are you going from condensation? Depends on what you're doing lah. Okay. So we got two types of latent heat: fusion and vaporization. Make sure you don't use the wrong one. Vapor means must have gas, either liquid to gas or gas to liquid. Okay. Fusion means solid, solid to liquid, liquid to solid. Okay. Now, the formulas that you might use: Q equals to ml. L is all latent heat. L is latent heat. Okay. Either one also L. M is mass. Q is heat energy. If they tell you what is the heat absorbed, or they tell you what is the heat release, that is Q. But if they give you, let's say, 50 watts heater, you see this W or not? W means you must use P. And then the time is in seconds, like 30 seconds. The time must be in seconds. And then the power is in watts. Okay? If let's say there are two objects both also change phase. Okay? Two objects both also change phase. I cannot think of any example now where two objects change phase. But if got, then it's ml equals to ml. But let's say one of the objects become cold, the other object change phase, then you use mc theta equals to ml. For example, ice put into water. Okay? So the ice will melt. Then he is ml. The water become cold. The water never change phase, so he is the mc theta. Okay? Or another example, I have a hot metal ball. Okay? Hot metal ball, I put on ice. Put on a block of ice. Okay? The ice melt. The hot metal ball become, let's say, okay, I don't want to use ice again. Hot metal ball put in water. Okay. Hot metal ball put in water. The water boil and become steam. The water boil becomes steam. Then I will say this is ml. The hot metal ball cool down. The metal ball never change phase, so I use mc theta. You understand? If you see somebody change their phase, then you use ml to calculate their thing. If you see somebody never change phase, you use mc theta. If two things together, you make equal. Okay, you make them equal. Just like that. Okay, now for essay, right? When I sleep, I suddenly got some inspiration for essay also. So one of the topics I got inspiration for is, let's say, EM wave. EM wave, you must make sure to memorize all the EM waves. Okay, all the EM waves. So we got radio wave, microwave, infrared, visible light, ultraviolet, X-ray, gamma ray. Okay, again, radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Now, the wavelength, longest wavelength is radio wave. Okay? Yeah, longest wavelength is radio wave. And then the highest frequency is gamma. Understand? So that means as you go down like that, the wavelength becomes shorter and shorter. As you go down like that, the frequency becomes higher and higher. So let's say they ask some questions between two waves. It could be any two. Let's say they ask microwave and ultraviolet. They ask you, look, which one the wavelength longer? You have to know lah, based on this sequence. Okay. So let's say like radio and micro. Radio, the wavelength is longer, which means it can spread more. You know why? Because longer wavelength can diffract, so it can spread to everybody. Microwave is higher frequency, so that means it can travel further. It has more energy, it can travel further, but cannot spread. No? He's not good at spreading. He can travel further, but not good at spreading. This isn't good at spreading, but cannot travel far. Okay? Good at spreading, but cannot travel far. So let's say the essay question asks you to choose maybe for satellite. Satellite, what kind of wave do you use? Then you can say, I use microwaves. Okay? Why I use microwave? Because it has higher frequency. Okay? Can travel further. Yeah? Radio wave cannot reach satellite. Radio wave cannot reach a satellite. Too far already. Okay, let's say they ask you for telecommunication. Telecommunication, then you choose geostationary. Why geostationary? Because it is always at the same location when you observe from Earth. Always at the same location when observed from Earth. But you must be careful. If it's not telecommunication, if it's not for live broadcast, you don't always choose geostationary. Okay? Normally, only telecommunication or live broadcast, you will use geostationary. Why choose high frequency? More energy, can travel further, or clearer signal. Okay? Clearer signal, right? Why choose low density? Because it is lighter weight. Yeah, lighter weight. You can say it is easier to launch to space also can. Easier to launch to space. All right. Why have more solar panels? Let's say you choose more solar panels. You can produce more energy. Okay. Let's say another thing they ask, let's say your antenna size or the dish size. You can say larger antenna or longer antenna. Okay. So again, longer antenna or larger antenna is, you can say, can receive more signal, or you can say can receive clearer signal. All right, so these are some common essay topics for satellite. Okay. The next thing I have some inspiration on is impulsive force. So for impulsive force, maybe you need to remember you don't need to remember but the formula is F equals to mv minus mu over t. mv minus mu, that is the change of momentum. So when you divide by time, we can say that it is the rate of change of momentum. That's the definition. Okay, rate of change of momentum. Yeah, m is the mass, u is initial velocity, v is final velocity, t is impact time. You want to reduce the force, you increase the impact time. You want to increase the force, you decrease the impact time. So let's say they ask you, I want to make a bubble wrap. I try to send things on Shopee. Yeah, online shopping you want to deliver the objects So you want to make sure to protect your object. So you want to design your bubble wrap. So we want to have more bubble wrap because you can have more protection. Okay, more protection. Yeah. You want low density because again it is a lighter weight. You can say it is more portable also. Use air to fill the bubble wrap. Okay, that way you can increase the time of impact. Increase the impact time, then you can reduce the impulsive force. Okay, if they ask you, should I have any shock absorber or not? Should I have shock absorption or not? Yes, you want it to have shock absorption to reduce the force on the object. Okay, to reduce the force on the object. If they ask you to choose, hey, my box should be big or small, of course you choose a big box, okay, to fit more bubble wrap. Okay, you can fit more bubble wrap inside. Yeah, so that's some things that I can think of lah, because I suddenly have an inspiration for bubble wrap. Okay, and then one more question will be the heat question lah. Let's say for design, they ask you to design. And before they ask you to design, thermal equilibrium, the definition for students in my class, you should know already lah, because I have discussed this with you all before. Thermal equilibrium will be two objects in thermal contact. Okay, and then net heat flow is zero. Net heat flow is zero, and they have the same temperature. Okay, they have the same temperature. In case they ask you what is specific heat capacity, it is the heat energy required to change temperature for 1 kg of substance. Again, specific means 1 kg. For 1 kg of substance by 1 degree Celsius. Okay, change temperature for 1 kg of substance by 1 degree Celsius. Now, let's say they ask you to design a thermos, a container for food. A container for food that I want to try to keep the food warm for as long as possible. Why do I choose something with low density? Because again, it is a lighter weight. It is more portable. Okay. Why should I choose a shiny inner surface? I'll suggest to them, you must have a shiny inner surface so I can reflect heat back into the food. Okay, I can reflect the heat back into the food. Yeah, back into the food. They will ask, what about the walls? Do you have any suggestions for the walls or not? I will suggest to them, you can have a double layer wall, or you can have a hollow wall. Hollow means inside is empty one. Your wall got air in between one. Okay? Yeah. So you can say this is to reduce heat loss through conduction. Okay? Or you can just say reduce heat loss to the surrounding lah. Yeah? Why? Because if you have air in between, air is a very poor conductor. It's a very poor conductor. Yeah, that's another point also. Now, if they say, what should you have in between the two walls? Let's say they already show you it's a double wall. What do you have in between the two walls? You say if can, you put vacuum. If cannot, you put air. Air is a poor conductor, but if can, you put vacuum. So again, same thing, to reduce heat loss through conduction. Yeah, reduce heat loss through conduction. Or reduce heat loss to the surrounding. Okay? If they ask you to suggest them based on the specific heat capacity, you can suggest to use a high specific heat capacity. Why? So that it does not cool down quickly. Okay? It does not cool down quickly. Yeah? Use a high specific capacity. And lastly, right, if let's say they ask you to do some suggestions, to give some suggestions in terms of the size or the capacity, you can suggest them to use a larger size thermos or a larger capacity thermos, because then you can store more food. Okay, so these are just some sudden inspiration I got lah when I was sleeping and daydreaming lah. Huh? Don't ask me where I got these questions from lah, where I got these topics from. Okay, I got it in my dream lah. Okay, so I will leave this PDF also in the link down below. Yeah, I will provide a link to the PDF so you can download and you can read it also lah. Okay, yeah, so share these videos with your friends. Okay, don't just keep it to yourself only, right? So help out each other. Okay. So because I don't really have time to make a more detailed video already. Yeah. So this is the best that I can do lah. Okay. So yeah, good luck in your exams, everybody from Selangor. Okay. I'll see you next time. Bye bye.